Hello again. Let's get started. Now, I picked up a tough example just to drill everything on home. D by dx of the fifth root of x plus the sixth root of x. Yikes. But let's not panic. That's d by dx of, now the interior is just x plus x to the 1/6, and we're raising that all to the 1/5 power on account of the fifth root. So we just need to do the chain rule. Now, guys, we're going to have to let u, I didn't specify, sorry about that, and I should have done that. We're going to let u equal x plus x to the 1/6 power. You might could tell. Okay, u is going to be just the interior crust, x plus x to the 1/6. Okay, and a little space there. Okay, so let's get started. So by the chain rule, dang it, it wrapped the line badly there too. So by the chain rule, I'll show you the chain rule once this gets unwrapped. Okay, it's acting badly. So let me see. Okay, so by the chain rule, what you do is you turn this x plus x to the 1/6 into u. So do d by du of u to the 1/5 times d by dx of the u term, where u is this. So this is my u term. That's just a good old chain rule. So what I've got is, guys, I just use, remember the derivative of the sum is the sum of the derivatives. So really I could just go ahead and execute. And this wrapped quite terribly. So let me scoot that down a notch and scoot that down a notch. That didn't behave the way I wanted it to behave in terms of spacing. I'm a bit of a spacing perfectionist, as you've probably noticed. So let me, and that's terrible too. Let me space that down. Okay, I think I may have it. Okay, I think I like, that may be good. Okay. Okay, so here we go. So here's the chain rule right here. D by du u to the 1/5 times d by dx of the u term. And so it's d by du u to the 1/5 times, actually, sometimes in problems past I've been skipping this step, but I just go ahead and do it. Remember, the derivative of the sum is the sum of the derivatives. Here you go. Well, d by dx of x is just 1, and d by dx of x to the 1/6, that's 1/6 x to the negative 5/6. Now, d by du of u to the 1/5, that's 1/5 u to the negative 4/5. So, and we're multiplying it distributively by the stuff inside here, okay? Whew, okay. But here's the thing. U to the negative 4/5 is that's not going to be that well behaved. I go ahead and I take the liberty to do something. And yeah, I take the liberty. I do some algebra that you may find heavy going. I tell you what, if you want to, since this example is just to bring home the power rule and the chain rule anyway, that's why I did this example. You can go ahead and just bring this u to the negative 4/5 down here with the 5, and you'd have 1 over 5 u to the positive 4/5 all down here. If you'd rather do it that way, that's fine. Because, but anyway, what I do is an algebraic sleight of hand. Negative 4/5 can be thought of as 1/5 minus 1. And negative 5/6 can be thought of as 1/6 minus 1. And you're like, well, Jason, why'd you do that though? I did that because of this. Remember, by the law of exponents, this is just 1/5 u to, we got the 1/5, we got the u to the 1/5, and then times u to the negative 1. By the law of exponents, we would have 1/5 times u to the 1/5 times u to the negative 1. But what that amounts to is that u to the 1/5 stays up here. That 1/5 can just be thought of as dividing by 5, and that u to the negative 1 can be thought of as just having a u down here. Okay? And then, now, the 1/6 right here can be thought of as just dividing by the number 6. And then the x to the 1/6 stays up here. And then, so we got 1/6 times x to the 1/6 times x to the negative 1, and that x to the negative 1 comes down here, and that with this 6 right here, okay? So we got all this. What this does is I don't want negative exponents, and I did some finagling to get out of it. There's other ways you can do it besides what I did here, by the way. Okay, but we need to replace u with what u is. Remember, u is x plus the 6th root of x. So I replace u with that. So the u to the 1/5 is the 5th root of u, but u is just this guy right here. And then 5u, again, u is this guy right here. We have to have parentheses around u because we're distributing 5 through this two-term expression here. In terms of x, u is a binomial. Well, it's not a binomial. Excuse me. It's not a polynomial at all. It's just a two-term. It's two terms being added together. This is not a binomial. It's not a polynomial. Sorry about that. So, but it is two terms being added. It is a two-termer, two-term expression, and we're going to multiply it distributedly by 5. Of course, is there any real point in distributing the 5? We can validly do so, but should I really do so? Is there really any point? I don't believe so. Not that I see. And you have a question that you have the right to ask right now. How do I get rid of this x to the 1/6 down here? Indeed, that is a hard question, but one we need to address. So let's address it. It's going to be with some pain that we address it. So that question we must address. First off, let's get the little things right. So let's just go ahead, see this x to the 1/6 power, let's just go ahead and write it as the 6th root of x. So let's at least get everything in good form. Let's get the little things down pat. Now these down here, I'm going to leave them in fractional form for the time being because it's going to come in handy. But anyway, let me do, well, what I'm going to do, guys, is I'm going to filter out, let's see, well, yikes, I do something else, don't I? Yikes, that's not the only thing I do. I forgot to explain what I did. I filtered out, you see this x plus x to the 1/6, I did more than it seems. I filtered out an x to the 1/6. I can factor out x to the 1/6 here. That's going to subtract 1/6 off these exponents. So this is an understood 1 here. 1 minus 1/6 is 5/6. And then, but now 1/6 minus 1/6, that's x to the 0, which is just plain Jane 1 base right here. Okay, so I factored out x to the 1/6. I divided, so you divide both of these guys by x to the 1/6, which means you subtract the exponents by 1/6. This x to the 1 becomes x to the 5/6. This x to the 1/6 becomes x to the 0, which is just equal to the plain old number 1. So, and here's that x to the 1/6 that I filtered out right here. Sorry about that. And then, yeah, sure, it is true. This x to the 1/6, I went ahead and wrote it as the 6th root of x. But that was trivial. Okay, now I'm going to leave these fractional. Now, the next thing I do, I made a mistake at the end of this problem that I need to correct. The next thing I'm going to do is this. I am going to, in red, I'm going to stick an x to the 5/6 up here in the numerator, and I'm going to stick an x to the 5/6 down here in the denominator. By commutativity, I can put it where I want it, and I'm going to put it where it's handy to have it beside this x to the 1/6. And by associativity, what I'm going to do is this x to the 5/6 is going to bump into this, multiplicatively, into this x to the 1/6. You're going to multiply them, and you'll get just x to the 1 power, which is x itself. That's the whole motive. We don't want fractional powers on our denominator. We just want x to the 1 or x to the 2 or whatever. But anyway, let me explain what I do here. Now, but I do more than that. Now, what I'm going to do is I'm going to substitute, see this x to the 5/6 here, I'm going to substitute it with a, with the letter a. I'm replacing x to the 5, temporarily, not for good, I'll come back to x later, but I'm temporarily replacing x to the 5/6 with the letter a right here. Follow my cursor real close. I'm replacing this guy right here with this guy right here, okay? And, well, this x to the 1, you know what? That was actually silly. I should have just, it's okay. I'm not going to go back. This 6th root of x, it would have been just as well if I'd have left it as x to the 1/6 power. It was kind of silly and pointless for me to write it like this, but oh well. It's not wrong, but I'm just going to turn it back into x to the 1/6 power here. You'll see why later, okay? Now, so I've replaced x to the 5/6 with a, and I've stuck these red x to the 5/6s, let's see, up here and down here in front of this 5. By commutativity, I can do that. I don't have to stick it to the extreme left if I don't want to. I don't. So, and indeed, I did not want to down here. Okay, now here's the deal. What I'm going to do is I need to correct a mistake I made at the very end of the problem. So, but we'll talk about that in a minute. I'm not. Well, that mistake is going to hit me right here. That's going to be. Let me go ahead and start correcting that now so you won't get the wrong idea. That's a 5 right there. Okay, but anyway, what I'm going to do in red, I'm going to stick this guy, this big thing down here, and this big thing down here. Remember, A is really just x to the 5/6 power. So remember, if we were to write this out as x to the 5/6, it would be ugly. You see, I want to have A. Because this would be x to the 25/6. This would be x to the, 20/6. That would reduce to x to the 10/3. But anyway, this would be x to the 15/6. You'd multiply 5/6 by 3. You'd have x to the 15/6, which would reduce to x to the, 15/6, 5/2 power. And I don't think I made any arithmetic mistakes along the way. And then minus. Notice I alternate between positive, negative, positive, negative. I do that for a reason. But can you see why I don't want to have this as x to the 5/6? I can do it all right, but it'd be a royal pain. Like x to the 5/6 squared would be x to the 10/6, which would be reduced to x to the 5/3. And then the A would, that would be all right. That'd be x to the 5/6 himself. All right, and then minus 1 is just himself. Well, minus 1. There's nothing to do. But these others are painful. But so now I stuck that guy up here, but the whole motive was actually to stick him down here. I want him, by associativity, I'm going to multiply A plus 1 times this big guy right here in red. And you'll see why I do that. It's going to involve, by the laws of algebra, that's going to be A to the 6 minus 1. A plus 1 times all this big jalop, this alternating jalopy, this fifth order jalopy in terms of A. If I multiply this jalopy in red here by A plus 1, I get A to the 6 minus 1. So there's that. Now, notice, that's good, but it's going to be good. You're like, well, what was the purpose of that? You'll see in a minute. And I didn't mess with this guy here. This guy here just copied and pasted. Now, another thing I did, you see this x to the 5/6, I move him by associativity, commutativity, and distributivity. I can move this guy over here and distribute him through this guy. This x to the 5/6, instead of taking him, he can't really do much with this guy. But what I did was I took him over here and distributed him through this guy. X to the 5/6 times 1 is x to the 5/6 distributive, and then plus distributive, x to the 5/6, I bring him up here in the numerator. If you multiply this a fraction by x to the 5/6, that's like having x to the 5/6 in the numerator of that fraction, or imposing x to the 5/6 into the old numerator of that fraction, okay? So x to the 5/6 imposes himself up here, but he's going to bump into x to the 1/6, and by the laws of exponents, you add the exponents. You multiply the terms, but you add the exponents. 5/6 plus 1/6 is 1, so it's just x to the 1 power, which is just x himself right here, okay? And so I did that, and then you might could tell, yep, after you do that, this x right here and this x right here will subsequently cancel, and you'll just be left with 1/6. And sure enough, there it is. So that's what's going to happen there. And now, guys, that you've got to replace A back. You've got to put parentheses. What is A? A is x to the 5/6, remember. That's what A was defined to be from the beginning. So we replace A, you got to put parentheses around it because you got to put an interior set of parentheses around it because you're raising it to the 6th power. So you got x to the 5/6 to the 6. And now by the other laws of exponents, you do 5/6 times 6, and that's 5. And I've got to correct the mistakes I made. Well, if it'll let me and not be a bear. So now, guys, what I do is now A to the 6. Remember, x to the 5/6, this is going to be x to the 5th. So I made a little boo-boo down here. This should be to the 5th power. Sorry about that. Let me correct that here. And let me correct that. Well, it's been a little obnoxious right here. And I'll need to also correct that right here. Okay. These are x to the fifth powers, not just x. Okay. So we have that, and I'll save that. And let's save that. Now, notice, I don't have any fractional exponents in my denominator, so there's not going to be radicals in my denominator. So what I've got, and notice another thing I do, I go ahead, well, after I get this 1/6 cleaned up, I'd clean this to 1/6, you can get a common denominator. You see this x to the 5/6? I go ahead and write it as 6 x to the 5/6 over 6 in order to have a common denominator of 6 here and 6 here. And then what I can do is just add the numerator, bring this fraction together as one consolidated numerator. Okay, like that. And I still have this same old guy over here. And then the final thing I can do by commutativity and associativity and all that, I can multiply this 6 and this 5 and get 30. So I just get 30. And that takes care of, I don't need these parentheses anymore. So I bring the 6 together with these guys. It's going to hit that 5 multiplicatively and give me 30. And then here's my x to the fifth minus 1. And then I bring these two numerators together. I put parentheses around this gobbledygook, and I put parentheses around this gobbledygook. This guy right here would technically distribute across this guy right here, but that would be messy. You would have 6 times the fifth root of all this junk times the sixth root of well, no, let's not do that. No. Actually, no, back up. Let's not do that. Just leave this alone. Guys, please don't distribute this. This would be quite messy. Our whole point, all I wanted to do was get the radicals out of the bottom and the fractional powers out of the bottom. Let's not go into overkill. Well, if you were to distribute this, you would have to, see this fifth root of gobbledygook, you would have to stick that in front of the 6 right here. You'd stick it, it would be cleanest, just stick it between the 6 and the 6 root. So you'd have 6 here times the fifth root of all this stuff in the middle times the 6th root of x to the fifth, and then plus, and then you would have this fifth root of all this junk again times 1, but that would just be this fifth root itself, okay? I don't advise doing that. That would be rather pointless to do. It would be correct, but pointless, okay? Guys, let me stop the video here. That's enough. I'll see you on the next video. Bye.